here? Yeah. So Retta, do you want to take
yes,
over?
I am.
Yeah.
Okay, so I guess we can start with the first AMA. So this first AMA will be featuring two people. So Kim Keaton, who is a principal engineer at Google, and Ramsey Arpasi-Duso, who's a professor and chair of computer science at University of Wisconsin-Madison. So you'll have a couple minutes for the presentation and to ask some questions on the Slack thread, like Amy said, please. And we can start going with it. So I guess for an AMA format, maybe it's better if we let both speaker present themselves. It will be probably more interesting than if I do a Wikipedia-like presentation.
Sure, Kim, why don't you go ahead?
That's fun.
Yeah.
Hi, everyone. Thank you so much for inviting us to be here today to talk with you all. So let me see, I'll tell you a little bit about myself. So Ramsey and I actually met in grad school. So if we go back all that way, so I got my undergraduate degree at Carnegie Mellon. I majored in computer engineering and public policy. And so from there, I went to Berkeley for grad school, which is where I met Ramsey. And I went there for both a master's degree as well as a PhD in computer science. And from there, I then moved to Hewlett-Packard Labs, where I was looking at storage management kinds of issues. Basically, how does one design storage systems so that they're easier to take into consideration performance and availability characteristics and requirements that administrators have? And so from looking at storage management, I moved on to more looking at information management and how can we organize and understand and search information inside of an enterprise more easily. And some of the research that I did there then was actually transferred into product. So I had the opportunity both to see the research side of things as well as the product side of things, where I was able to work on production code and actually talk with customers and understand some of the problems that they have and hopefully help to solve them. And then from there, I started working more on novel memory technologies, so things like non-volatile memory and disaggregated memory systems, and spent the last few years doing that. I recently joined Google in the systems research at Google Group, and I'm excited about the work that I'm going to be doing there in the coming years. So in my spare time, I love to sing. And so I've been singing with a choir for about the last 20 or so years. And we've had a chance to do some really interesting things. So love the opportunity to do musical things and to travel and have all sorts of adventures. So with that, I will turn it over to Ramsey.
Thanks, Kim. And thanks everyone for having us. Certainly very flattering, despite being more senior members of it. But that's life, I guess, when you get older. So anyway, for those that don't know me, I'm Ramsey Arpasi-Duso. I guess about myself, I grew up in Michigan, actually went to Michigan as an undergrad, went to, as Kim mentioned, Berkeley as a grad student. And in kind of at that time, well, I guess a lot of things happened in my life. One, I met my wife, so Andrea, who she was Duso and I was Arpacci, and we kind of stuck the two names together. And then got a master's and PhD, just like Kim too. I guess even the smaller world there is, Andrea and Kim have known each other since undergrad when they were doing projects together of whatever type as computer engineers. And then since graduate school, I've been a professor here at Wisconsin for 21 years. I'm currently also the department chair, and really have been working on systems problems mostly related to storage for almost that whole time, really. That goes back to, a project we did where we realized it's in grad school, like that I/O was kind of interesting. And that led to kind of a whole career. We've also, on the educational side, we've kind of accidentally wrote a textbook in operating systems called Operating Systems 3 Easy Pieces. It's freely available online. And other than that, I guess I also enjoy singing, but just by myself. So not a good singer, like but who knows what I do in my spare time. We have, for the last 20 years, we've also had two daughters running around. Now they're slowly disappearing. So we're getting ready for that next phase of life where the house is much more quiet. So in any case, thank you for having us. Really fun to be here, and nice to see Kim too. After it's been a little bit at least since I think there's some pandemic going on. So
Yeah, something like that.
Nice to see you all, and thanks for having us.
Okay, so I guess we can get started with the first questions. And maybe with this new information we have, maybe we'll finish with a singing contest at the end of the AMA for the 5 last
I
minutes.
wouldn't recommend that over Zoom, in all honesty. Although we could certainly try, it'd be fun.
So the first question is from Amy. So what do you think the systems community should be working on, but is not working on? So
Go ahead.
It's an interesting question. It seems to me like there's research that's driven more from technology trends, and we saw that a lot when we were grad students. A lot of the work that was being done at Berkeley at the time was very much driven by changes in the relative balance between the speeds of networks versus memory and storage technologies, the advent of new kinds of processing devices. And today we have lots of accelerators that we can potentially figure out how to use. There's also, so that's kind of bottom up, technology driven types of research. But then there's also, changing usage patterns and sort of, what are the requirements that we're placing on these computing devices? And so, there have been quite a few, things evolve over time, whether it's looking at more data intensive kinds of applications, whether it's thinking about machine learning and deep learning and whatnot. And so it seems to me like there's always this, a never ending supply of new technology, never ending supply of changing usage patterns. And so, always keeping an eye towards both of those things and figuring out how we can make systems work more efficiently, figuring out how we can make them not ignoring non-performance goals. So, making sure that we also keep an eye on the availability of those systems, keep an eye on the reliability of the systems, security, the manageability of those systems. I mean, it seems like those are kind of omnipresent sort of needs that the community has for us to be able to do research in those different dimensions. And so I think, in terms of things that the community is not doing that they should be doing, I think it's really, it's really sort of keeping an eye towards, what are the needs of applications and users of systems, as well as what are the new technology trends. And so I think that there's always going to be something interesting to be done there.
Yeah, that's a great answer. And thanks for starting. Tough question, of course. So it's a big question. And I think Kim make some great points. When I think about that question, I kind of answer it instead of saying, hey, we should just work on this. I kind of try to think about it kind of one step up from there. And, one thing I think about with academic communities, which I've, kind of observed for many, many years now, going back to even kind of undergrad days, is there are like certain problems that are very amenable to academics. And because they have like a certain kind of intellectual complexity. And then there's problems that are like important for the world. Like we think that we need to kind of advance and to make progress. And those two don't always overlap. So kind of like a meta way to think about this question of what should we work on is maybe not to be afraid. It's easy, I think, to kind of say, like, let's work on things that academics work on. And I'm not going to pick any one thing that's like that, because it's going to end up insulting like thousands of people who've worked on some area. But there are things that, I think it's really easy to shy away from things that are important because we don't yet see the novelty, and we don't yet see the kind of the academic way of exploring it. So I guess kind of a high level way of thinking about it is like, think about what's important and work on that, and you'll figure out the novelty as you go. I think another kind of meta comment that came to mind is, we live in, it's like such an unusual time to be, we're in the infancy still of this era of understanding computer science, right? We're still in the first decades of computer science. 1,000 years from now, people will look back on this time as when this thing was founded that obviously transformed the world. And so, now we're in, and when I think about that, I think back to when I was first in the field, it was a pretty small field. There was a narrow industry that focused on certain types of problems. And then, flash forward 20 years, and suddenly, of course, we're influencing everything. Which also means there are the biggest companies in the world, like Google, for example. They spend a lot of money on building computer systems. Companies like that are doing lots of things. And so I think the danger for academics is, again, this is kind of a meta comment about what should we work on, is we have to be really aware of what's going on in the real world. I think it's very important, especially in systems research, to be very connected to what's going on at Google and Facebook, et cetera, so that you know technically the things you're working on, you know, are different than something that they're already going to be spending billions of dollars on, but you know, be also maybe have some relevance in the world. so those are really kind of some meta comments, thinking about what should be working on more, which is, you know, think about important problems and don't be shy about working on them, and then make sure you understand what's going on in the world. Now, there's there's probably some broader philosophical questions of like, shouldn't we just all be working on climate change, because that's a big problem. But maybe I won't go down that path right at the beginning of the day.
But there's certainly, you know, certainly ways that we as computer scientists can help with these societal problems for sure.
Yeah.
Right? You know, and so there's a way to contribute to the world while being a computer scientist.
Yeah, absolutely. I mean, you can, to some extent, there's like a small way of doing it, right? Which is we make things more efficient. So efficiency is a power savings and is a good, right? I do wonder though how far that will get us, right? If we stay in that box. But like I said, it's probably a broader discussion.
Right. No, I would agree. And to your point, I totally agree that, you know, there needs to be cross-pollination between folks who are in academia as well as folks that are in industry, and you know, that happens in a bunch of different ways. That happens by going to conferences and talking with people, you know, in the virtual hallway track, and hearing about the work that's being done at these various institutions. That happens by doing internships or, you know, or sabbaticals and whatnot in, you know, in different places than the place that you're normally at. And so I think that there's, you know, there's talking with your friends that actually work in various places. And so there's lots of ways to get that cross-pollination and understand, you know, what problems people are working on, what techniques people are using to solve those problems, so that we can learn from each other.
Yeah, I have a follow-up question about like the interface between academics and industry, and also about what we should be working on. Isn't there like not necessarily a risk, but that academics starts working kind of for industry and not necessarily for research, quote unquote? And I mean, interesting problems are posed by industrials because they actually have the problems. But isn't there also a possibility that we as academics start basically working for companies without really working for them?
Well, what does it mean to be working for a company? I mean,
like solving problems for companies without actually being paid by the company, let's say.
Well, but I think so interesting problems are interesting problems regardless of who's paying, you know, and so I think that we need to keep that in mind, you know, in terms of so I as a researcher, I guess I think of myself as being a truth seeker, and you know, so trying to find the answer to a question. And so I think, you know, that question can come from a bunch of different places. You know, it could be coming from motivated by, you know, users that are using large scale systems, users that are you know, sort of finding that they're trying to do something and the existing systems aren't helping them, and we need to design a new system to do that. It could come from the fact that I'm looking at some algorithm and realizing that there's a really inefficient way of doing it today, and there needs to be a more efficient way of doing it in the future. And so I think, you know, there's a bunch of different sources of those problems. You know, some industrial users are, you know, sort of one example of that. You know, I think that there's a host of interesting problems that are suggested by what's going on in industry in terms of, you know, what academics are working on, and whether there's an opportunity for them to be kind of boxed into you know, sort of a more narrow set of research questions if they sort of only look to industry for those questions. You know, I think that there's a broad enough set of really interesting questions there that I don't think that it's necessarily narrowing. And so oftentimes the way that academics view a problem that has come from an industrial context, you know, they're not solving the specific problem that someone has mentioned. Oftentimes, if you don't know how many of you have had the chance to, you know, have real users of the systems that you build, you know, but the kinds of questions that users have are often very, you know, they're very immediate, and they're concerned with the problems of today and not really trying to anticipate what the problems of tomorrow might be. And so as a researcher, what we want to do is not just listen to what they're saying today, what the problem that they're having. I mean, the problem could be that, well, gee, I couldn't get, my computer decided to, update itself this morning, and that took way too long, and this is what's top of mind for me today. That's not really the problem that I'm trying to anticipate. So I think, as researchers, we need to think about anticipating the problems that are happening, being able to extrapolate and generalize from specific problems that people point to us. And so even then, if you're starting from something that came from a real set of users, there's going to be a sort of a longer term kind of view of this, and and a more a rich space to work as a researcher, whether you're a researcher in industry or in academia.
Yeah, that's a great answer. I think about it, and I think I do appreciate the question. I think I understand the concern of just becoming, there's like a sense of industry is such a powerful force in our field. So we have to think a little bit about the kind of question that you're asking. To me, I think back to some examples, and I think Kim kind of touched on this. I think of examples where a problem kind of came out from an interaction with industry, but we were able to kind of look at it perhaps a bit more broadly or a bit more in a general context than I have to solve this tomorrow. So here's a quick example, which I'm sure I've told this story 1,000 times. But I was talking to some people at NetApp, and what they were talking about was this problem that they were having with, it was just kind of randomly chatting with engineers. And this is why I always tell people who are new academics, find excuses to talk with people who are working on real problems. Interesting things come out of it. And the specific issue there was that their file system checker, someone had called and said, how do you run the checker? And they told them, and then the customer said, okay, and they typed in some commands to kind of recover an important volume which hadn't been backed up, and they needed to recover it. The customer did. And then the customer called back 2 days later and said, when does the checker stop? It's still running. It's been 2 days. And that's just kind of an interesting, funny anecdote, how the checker was running forever on this huge volume. But it made us ask a question, what would it take to write a really fast checker for very large volumes? And we wrote a paper about it, and pretty soon that kind of got adopted into some real checkers in the world, some of the ideas that we had. So I think there's always the opportunity when you connect with industry and you hear about real problems, is to kind of take a step back and ask, is there some interesting academic kind of research question that you can explore that, maybe somebody in the throes of it they're not going to step back and say, hey, what should I do? They're not going to say, hey, how should we rewrite this checker? They're going to say, how do I solve this customer's problem? The other thing I would say is, I think the real thing to be worried about is not so much having a problem that's created by industry or perhaps inspired by industry, but rather you don't want to work on things that industry is just going to solve tomorrow, right? If you know that it's some problem you hear about, but that they're just, 2 people work on it and then the next day they'll have a solution. Those are the types of things you want to avoid. Yeah, you could probably write a paper about some things like that, but it probably isn't worthwhile. So I think, you're trying to interact and learn about what's going on in the world. And then you're trying to take a step back and work on things that you feel like have maybe a broader view than it's easy to do from inside of an industrial lens.
Does that answer your question?
Yes, it
Totally
does.
poke on it a little bit more. Does it?
No, it does answer my question. So I'm gonna pick up some questions from the chat. So from Lin Yu from University of Wisconsin-Madison. So how to pick a research project at the beginning of a PhD? And I believe there was a follow-up question that extended the question to soon after the PhD, also in early career. So should you focus in your strong areas or explore new things?
Do you want to go with that, Ramsey, or shall I?
Either way, I mean, I guess we can rotate. Maybe I'll go first.
Yeah, let's switch up. Yeah.
Sure. Otherwise, Kim does such a nice job. It's always nice to follow her, actually. So that's a broad context. I could just add 2 opinions, but I'll go first. Sure. How to pick a research problem is it's a career question. You as a researcher, you constantly have this question: what should I spend my time working on? It's a great privilege to have that question, right? If you're a PhD student, you get to have it a bit. If you work in research, whether in academics or research labs, you also have it. It kind of hangs over your head a bit. I always find that every time we write a paper, I find myself thinking, how are we going to come up with another idea? Like it's always this, there's a stress to it, right? And I think it's okay to accept that, you know, it's not obvious where ideas come from. I think it's hard to come up with ideas, and it's hard to come up with good ideas. And so all you're trying to do is, when you're thinking about picking problems, is you're essentially trying to set the context for your kind of how you're doing your work, so that problems might appear, they might find themselves, they might find their way to you, I think, is the way I think about it. So what are some of the things you can do contextually to pick problems? You know, of course, there's one thing you can do, you can think, right? Like thinking is good. And that's a kind of a silly comment, but it also means that you should set aside time for thinking. Like some people don't recognize that, like people are so trained to work, right? Like that's, I mean, think about what you've been doing from, you know, kindergarten through, let's say, undergrad. You are trained to do school, right? That's what you've been doing. And because you're in graduate school, that means you actually did that really well. And you've been trained to read what's in front of you and do that thing. That's necessary for research. You have to have a backdrop of knowledge, but it's not perhaps sufficient. And so I think you have to think about how to set aside time to have time to think, you know, even on a daily basis, about the things you want to work on. Two, I think other contextual things that you can think about is, of course, reading, right? Reading is an important thing to do. You have to read what's out there in the field. I always caution people, like, you want to read enough, but not too much. If you read too much, you will very quickly convince yourself that all the brilliant people that came before you have discovered every nuance of every problem that you could ever think about, and why are you bothering trying? So don't read everything, just read enough. You know, the Jim Gray wisdom was read 20 papers in an area you're interested in, and that should be enough to kind of bootstrap your knowledge, and also should be enough, it gives you some ideas. So I think, of course, constantly reading and getting a sense of what people are doing, but in an area you're interested in, you know, read just enough. So, and then try to have something that you want to work on. I think in terms of picking problems, you have to also be deliberate in how you, you know, I said to think, but that also means to like take notes and to read through your notes. Like that takes some work and some discipline too. You know, I've said this before in other public settings. I have like a single file that I've kept since actually the first day I got to grad school. I just opened up an Emacs buffer and called it thoughts.txt. I didn't know I'd be living with that file for the rest of my academic life. And it's just a log of dates and things I was thinking about over time. And so I would try to record thoughts in there, not because my thoughts were great. In fact, they were often pretty stupid, but because then I could go back. And what I would do is I'd kind of rewind periodically, like go back 6 months and see what I've been thinking about. And that's, again, just trying to give yourself context to think about things. You know, a lot of people talk about ideas as like, where do they come from? And, you know, I remember hearing Steve Jobs talk about this, and it's about, you know, it's really kind of connections between things, right? So you're trying to give yourself some opportunity to connect things and come up with some space of ideas that maybe hasn't quite been explored yet. I think the last thing I'll say is, of course, we're in a systems field, so you have to do things. And so you often get to a problem because you were doing something else that was related to that problem. And then you kind of learn something from that. We were doing some work and very early on here, and we had, you know, just kind of recognized that like these file systems that we were messing around with were reacting to disk failures in kind of strange ways. And we had no way of talking about that. And we just kind of made this observation, like, why hadn't, you know, we've been teaching about file systems, but we didn't really know about why these behaviors were existing. Like, oh, on this file system, when the disk failed, it would crash, and this file system would try to retry. And we were kind of noticing all these things. And that led to, you know, like many years of study of kind of file system and storage system policies in reaction to failure, all from an observation that I remember literally sitting in this office talking with the student about. The student was kind of observing, oh, there was this interesting thing that was happening. I wonder what it was. So I think, you know, last point there is you have to, of course, find things to do. It doesn't have to necessarily be the perfect thing. Often you're working on something and it's kind of okay, but it will lead to the next thing. And so, you know, you don't want to be in a situation where you're trying to find the perfect project to work on for, you know, you're thinking for a year about that. That's very hard to do. I think you have to make progress through both thinking and doing and reading.
Yeah, I totally agree with the wisdom that Ramsey just shared. There's a reason that he's a faculty member and you give great advice to grad
Well,
students,
thank
I think. And so I think, you know, just building on that, you know, there are great ways to, you know, as a graduate student, I think, you know, you can read the future work in papers, you know, sort of thinking about what are the unanswered questions that this paper didn't tackle, you know, in the spirit of trying to build on either work that you've done, you know, as Ramsey was suggesting, you know, or work that others have done. And, you know, there can be often, you know, clues as to what are the interesting and hard and not yet solved problems in those future work kinds of sections. You know, I think a great opportunity to explore different things is, you know, in the courses that you take, there are probably course projects. And so, you know, that can be a great starting point for, you know, someone has already kind of formulated a version of a problem for you to look at. And oftentimes they're really interesting problems that if you work at them, you know, perhaps, you know, for the course project as well as a little bit longer, then, you know, that might actually result in a publishable paper, you know, and so it gives you kind of a springboard to, you know, to then continue the work, and actually, you know, answer a deep question. You know, I think that there's other kinds of really interesting opportunities, you know, not just thinking, you know, as a solo person, right, you know, but talking to people, you know, and sort of brainstorming with each other about what are the interesting ideas in a particular space. And some places organize their research as groups of people that can work together. And so, you know, having folks that you can actually collaborate with, whether those are folks, you know, that are working in the same area that you're working in, or potentially working in a slightly different area, and you can, you know, both bring different perspectives to a problem. I know I've had a lot of, you know, really wonderful research experiences by working as a systems person with folks that understand other areas. So for example, understanding optimization and applying optimization to some of the storage management problems that I mentioned a little bit earlier. You know, we were able to figure out how we could treat the question of designing a storage system as an optimization problem. And so I got to learn a lot about optimization from working with other folks in that space. And they learned about an interesting problem because, you know, they were trying to help to work together to actually solve this problem. So having an opportunity to collaborate with folks, especially folks, you know, where you're bringing different strengths and different areas of understanding to a problem, I think is also a very fruitful place to, you know, to understand and to be able to do really interesting research.
Yeah, thank you. So I guess we can go to Sarah McAllister's question. So what do you think computer science and the systems community in particular can do to increase diversity and inclusion?
That's a great question.
Yes, yeah, yes, important question for this workshop, I guess.
So in the spirit of tag your it, I can go first on this one. So I think there's always a challenge of how do we make it easier for people to enter our field. And diversity means a lot of different things, and it should mean a lot of things. There are many different dimensions to that. And so certainly providing access to role models, and people who, you know, maybe like you, or maybe they're different, but in a different way than you're different. And so essentially, you know, being able to see people that are like you doing these, you know, these kinds of jobs is a really important thing to increase our confidence that that's something that we might be able to do. And so, you know, part of that is coming to, you know, to research workshops like this one, where you can meet other people that may be, you know, different in the same or different ways that you are. I think more concretely, trying to find ways of demystifying the process. So when I say the process, I mean, that could be the process of applying to graduate school. That could be the process of finding an advisor, or the process of finding a research question to work on. That could be the process of going up for a promotion. It could be the process of applying for a scholarship. You know, and so the more concrete information that we can provide to people about how that works, you know, what are the things that I need to do if I'm interested in you know, making this leap and trying this out? What are the criteria that people look for when they're trying to make these decisions? You know, and sort of demystifying it so that it doesn't seem so hard. If you can see what the concrete steps are to doing something, then it's easier to, you know, it doesn't seem so scary anymore, I guess is really what I'm trying to say. So for example, you know, in an industrial context, I've sat on many different promotion boards. And so oftentimes it's confusing to know, well, you know, am I ready for a promotion? Am I not ready for a promotion? If I want to get a promotion, what do I have to do? And so, you know, in that particular example, being very clear about what are the criteria that we're looking for if we're trying to promote somebody, and making sure that those are published criteria, giving people examples of promotion cases that have been successful so that the people who are interested in being promoted can see, you know, what's a good example of this. And, you know, even better, if you can, is to provide bad examples, something that didn't, you know, that didn't quite make the bar. And so then, and also then providing, you know, more directed feedback on, you know, your specific case. So I worked with a number of people actually who are going up for promotion to give them feedback on the case that they're trying to make, so that they can, you know, sort of present themselves in the best light, and then work with them to try and prepare that package. So I think, you know, trying to demystify various processes is another way that we can make all of these various things, all of the steps along the way, seem more doable and less scary for folks. I think, you know, ultimately finding other like-minded people so that you don't feel like you're doing this all by yourself. You know, and so whether that's other folks that are at the same stage that you are, whether it's folks that are maybe a little bit ahead and, you know, have already been through some of the things that you've been going through, that can actually then help to, you know, help to demystify, help to actually show you, you know, an existence proof of how to do something, I think is also a really great way of trying to increase the diversity in the community.
Yeah, great points, Kim. I'll, you know, certainly echo all of those. You know, I think the point about role models is a really good one, and role models happen at, you know, it could be somebody who's just a year ahead of you in school, for example. I can't even remember the number of times at a graduation ceremony, for example, like a young woman graduating just recently, and she said, you know, when at the toughest time, like I wasn't sure I could be in CS, and then, you know, but then I met a few people who were just ahead of me and had gotten through this tough time and kind of got through the major. So, you know, role models can be, you know, people who are, you know, very senior and have had a long career, or they can just be, you know, someone who's a senior versus, you know, you're a junior. And I think it's important for everyone to recognize that they can be a role model simply by, you know, taking a step forward and kind of going down some path. I think that point you make, you know, you made some points about community, and one thing I think about are our environment, right? Environments are, and that's like work environments, that's school environments. We have to continue to work really hard on making sure our environments aren't turning people off and making people feel excluded. You know, kind of a personal story. My daughter, who is also an older daughter studying computer science, and at her like first kind of internship thing that she went to, like she walked in the door. Day one, there was two kinds of people walking in. They happened to be hiring like a lot of computer scientists and some designers. Immediately, they said, "Oh, you're a designer," because they were making a gender-based assumption. This is day one. And then the second, once they figured out she was a CS person, the boss asked, "Oh, are you good at math?" She said, "Yeah, I'm okay at math." And she asked why. And they're like, "Well, the last woman wasn't good at math." And I'm like, this is like day one in like the modern world that somebody's being asked a question like that. So she quit, which I was very happy with. I'm like, she's like, I'm not going to be at this place. But, you know, amazingly, and, you know, I'll hear things about that too, just not necessarily, it's kind of in these hidden places, right? Like it'll be students working together that don't treat everybody the same. And so we have to think really hard about how to make, you know, work on our environments so that, you know, when people decide to take a look, that's not the experience they have. And that's just an ongoing forever project, right? There's no easy answer to that. Of course, we've been thinking about this, the issues of diversity a lot, and I think in any university is. Some things that we've done are curricular. There's I think a strong belief here and many places that actually curriculum can affect, you know, who enters your program. So for example, a few years ago, you know, we were having the problem with intro courses that some people had a lot of CS before they showed up here and some people had very little. And that was already kind of encouraging people who hadn't had very much not to enter our field. So we've done some explicit things where now there are explicit tracks for people. Like it's 100% the reason you're taking this class is because you just haven't had CS yet. That's okay. and kind of to destigmatize that. It's made a little bit of a dent, but not a huge dent. The other thing that we've been really working on as a university, and I think a lot of places are doing this too, is really trying to provide many different broader pathways and degree programs that connect to the technology world. So for example, we introduced a data science major, which is, related, different, doesn't have some of the stigma of CS for whatever reason. And so that's, we have in some ways we've reached some more diverse crowds there. And over the next so many years, I think we'll be seeing many more different degrees and majors that are, related and allow people to enter the field without maybe some of the preconceptions they have. A third thing I think is just, that we all have to work on is how do we expose people to the fun parts of our field as early as we can, just because, I think the more people know about it, the more they don't have just a certain narrow view of what it's like. Like, I think we all know that it can be a really, I think Kim talked very nicely about collaboration has, been great for her career, learning about optimization, for example. Like, and those collaborations and teamwork, those are really natural for all of us who are inside of it. And we see all the fun of that. But I don't think that's how people necessarily view us when they're hearing about computer scientists. So I think there's always some onus on us to make sure that what we're doing is getting pushed down into a curriculum, but also in a fun way, right? In a way that gets people interested in our intellectual discipline, as opposed to turned off by it. I mean, Andrea, my collaborator and wife, she has done a lot of stuff with with the school systems just on the side. It's her fun extra job, I guess. And you'd be surprised by how many even school teachers are very interested in math, very interested in science, but find computer science is like, well, that's like technology, and completely disinterested in it, or just don't know anything about it. And so I think, and are kind of turned off by it even. And I think a lot of us view this as, well, math, science, CS aren't that different. So I think there's a lot of work still to be done and pushing down what we do so as to open up people's eyes to it and get them to think about it. And then of course we have to work hard on the landing spots, the community and environment, so that when they get there, they can feel a part of it. But yeah, still a lot of work to do, unfortunately. Yeah, thanks for the question.
Yeah, just one other quick point in addition to some of the great ideas that Ramsey was just mentioning. I think other environments have started experimenting with understanding implicit biases. And so there's a whole, if you Google implicit bias, or use it in your favorite search engine, there's a lot of really interesting work that's been published there, quizzes that you can take to understand your own implicit bias. But some schools and companies essentially have set up programs where they're bias busters essentially. And so in the spirit of, if you see something, say something, that you find in airports and public places for other reasons, the same kind of thing applies here to bias busters. And so people have very successfully set that kind of an environment up, just to kind of be able to point out when something might not be working for some community, and to be able to then understand that there's a problem, and then also hopefully take some corrective action. So implicit bias, check it out.
Yeah, thank you for both your answers. Let me check the most popular questions. Okay, so we have like a triple question from Kian Lee, Vishwanath Seshagiri, and Lin Liu. So I'll try to summarize them. So when do you decide if you should pursue, so how do you evaluate your research projects, basically? And when do you decide if you should either continue pursuing this idea, or if it's actually not going well, how do you decide if you should just backtrack a little bit and say something else, or completely stop pursuing this idea and start afresh completely? And if you decide to pursue the idea, how and when do you decide that it's ready for submission? Like, do you decide directly, like we should submit to this conference and then work toward this? Or do you first work the project and then decide that, okay, now that it's ready, let's submit it?
Yeah, great. I guess this is my turn to go. first.
Yes.
Sure. So when to continue or not, that is a tough question. And everybody faces that question because unless you're some sort of magician, not every project's going to go well, even ones that end up being successful. So you will 100% have moments where you wonder about that. Certainly I had many throughout my career. I remember in graduate school, I had first couple of projects went really well and ended up as published papers. So I felt like, oh, this isn't too bad. You work on something, it turns into a paper. That's how life will be. And then I think the third thing I was working on, it started as a class project and it kind of had some success and, it looked like it was going to be interesting. And then, just kind of the months kept adding on and, we were trying to do some binary instrumentation of operating systems, which is like already kind of like a very technical kind of thing to be doing. And the tools weren't great. There was kind of no internet. So like there's no web where you could just find a bunch of information, right? So it was always hard to figure stuff out. And it was just kind of taking a long time. And we weren't kind of getting to the research questions. It was just more like every day some new thing would break. And, maybe it was, I don't know, it just wasn't quite exactly what I was enjoying doing either. And I just remember having a conversation with my advisor about 6 months in, it was pretty clear we were pretty far away from a real research result. And he said, I was very lucky. I have a good advisor like him, Dave Patterson. And he said, let's just declare victory. And I'm like, what does that mean? He's like, let's say we did this thing and now it's done. And let's move on to the next thing. And I was like, that sounds great. And I felt really happy. And I knew it was the right decision immediately once he had said it. I hadn't really realized that was an option.
I have to say that has become one of my favorite phrases.
Yeah,
I declare victory all the time on various things. If a meeting is like really contentious and we're not getting anywhere, I'm like, let's declare victory on this and move on. So great phrase to introduce into one's vocabulary. Sorry to interrupt, I just wanted to share that.
No, it's funny that it's like those things stick with you, right? And so like then the question becomes like, so it's okay to do that. Now, of course, if you become a person that works on things for 6 months, declares victory and moves on to the next thing, and you do that repeatedly, well, pretty soon you're going to have something that's called I left school without a PhD. So you have to be a little careful in declaring victory. I think the way I think about it, and students, especially with students, is you have to be willing to kind of dive into something. I call it kind of, it's like a horse with the blinders, right? At some point you have to put on the blinders and just kind of try, kind of go in, do the thing for a while. You don't want to be waking up every day and asking, is this worth doing? Like it's too hard to work on something. It's too hard to make progress. So you have to be willing at some point, what you kind of do, and this is why it's nice to have advisors, right? Advisors have a sense of, sounds like a research problem, let's spend some time on it. Or just to be collaborators, or it can be your own sense, of course. But usually what you're trying to get to, like, let's say you're a student with an advisor, is you're trying to get to, yeah, this sounds good enough to for us to put on the blinders and try to work on it for a while. And then you go try it, and then you see what comes up. And then you do all those things we talked about earlier. You take notes, you think, you read other things, you do the work. And then I think it's good to come up every so often. Semesters are useful because, you can think of like, what did I get done in this kind of 4-month period or summer? So come up at the end of that time and say, hey, where are we? And then kind of evaluate, take the blinders off and say, are we really making progress towards the bigger question? So that's kind of how I think about whether to continue on something or whether or not, like, periodically you can ask that question. Don't ask it every day. And of course, talk with people about it, like advisors and things like that. As for the paper question about being ready for submission or not, I think it's always good to have a deadline to work towards, because it's amazing how much you get done in the 2 weeks before the deadline. Even if you don't think you're that type of person, you get more done, and it's good to try. And then as you get within a few days of the submission, you should ask yourself, is this really the paper I'm happy with and proud of? And did we actually do the things that we were setting out to do? And if you did, then you should submit it. And if you didn't, then you shouldn't. And you shouldn't just say, well, we're just going to throw it out there to get some advice. Like, don't do that. There's already too much work for people to do. Like, if you're submitting a paper, feel like you feel like this is a good paper about this topic. Don't feel like it's just where we are right now and we're going to get a status check from the community. That's just wasting a lot of people's time. Not that anyone would do that, but there's a temptation. It's kind of like a free feedback service. So don't give in to temptation. Wait till what you think. You're like, hey, I'm proud of this. I'm happy with what we've done. Then feel like it's okay to submit.
Yeah, no, there's a lot of really great advice in there. I think in terms of how to decide whether you're making progress on an idea, I mean, I like to think about things as, how am I going to know if the answer is yes or no, right? How am I going to recognize a good idea? And so if you can think ahead of time about, if this is a successful idea, how is this going to make the world a better place? How am I going to evaluate it? Is it going to make something more performant? Is it going to make something, more reliable? Is it going to make something easier to manage? Along any of those dimensions, how am I going to evaluate that? What are the kinds of experiments that I'm going to do? And, what's kind of my mental model for the good result that I'm going to see? And so if you can think ahead of time about what some of those questions are that you're going to try and answer, then I think that can be a really great way of sort of, as you're working on something, sort of checking in to see, is this a good enough idea? Am I getting the kinds of results that I thought I was going to get? And, and if not, then, either maybe you're not quite there yet, or, maybe the question that you're asking is, is the research direction that you're going in isn't necessarily the more interesting question. Maybe you need to sort of, adjust the question a little bit because you've actually stumbled upon, an interesting problem that wasn't the original one that you thought you were working on. So I think, having a sense of how am I going to make the world a better place and how am I going to measure that, and then checking in with that can actually be really useful for for evaluating a particular system. And in terms of sort of whether or not to submit things, I think I've had experiences where I think one paper we submitted some version of that 5 times before it was accepted finally. And so sometimes, if you've done work and, and it maybe didn't quite pass muster, for a given submission, being persistent and if there's some interesting work that's going on there, sort of doing, taking the feedback that you get from the community, and then trying to incorporate that and actually, sort of building on those results, and then, sort of being persistent and continuing to try to, to try and get something out there is definitely another life skill that is very, very useful to, to learn.
Thank you for both your answers. And now the next question, who won by popular votes? So from Natasha. So going back on the topic of role models, how can one try to be a good role model for younger students? So even as a junior or senior PhD student, and what balance should one strike between helping the others and working on one's own research? Or is that even a calculus that makes sense?
I think that's my turn to go first. I think
Yes.
one way that we can be good role models is, just merely by being us and doing what we do. And in our success and in our learning, we can provide an existence proof for others. And so I think that that's something that we need to remember, that just by doing what we would normally do, we're making the world a better place. In terms of actively helping people, I think that there are lots of opportunities to do that. So for an example, oftentimes as a graduate student, more senior graduate students will work with more junior graduate students, potentially even with undergraduates, on a joint research project. And so, this can be a really wonderful opportunity for you to have a built-in collaborator. You can have someone that you can work with. You can have someone that you can mentor throughout the process. And then you also have someone that can help to, sort of brainstorm ideas, can help to implement things and whatnot. So I think that there's a symbiotic relationship that can be formed between more senior people and more junior people, in terms of getting interesting problems studied, as well as providing opportunities for people, both more junior people who are learning from the more senior people, as well as more senior people, sort of having the opportunity to, to help shape the career of that more junior person. And also, both parties will then benefit from the results of that collaboration. So again, that collaboration theme comes back to to really sort of be a vehicle for actually allowing us to mentor and provide role models for people. I think, in terms of striking a balance between helping others, versus doing your own research, they're not necessarily completely separate. As I was just saying, that oftentimes there can be opportunities for working with people, and sort of where both parties can actually benefit from that relationship. In terms of strictly things where one is only helping with others, there's there's a giving back sense of things. So as you work your way through your degree program, and as you work your way through the rungs of the ladder of wherever you end up, people have helped you, and so it's you pay it forward, basically. And so there's there's a certain amount of wanting to help the community in the same way that the community helped you. And so I think that there's certainly a role for that, even if you're not getting anything from it. But then in terms of deciding how to balance your time, you certainly have to have to pay attention to to being able to get your own work done. But it's useful to reserve a certain amount of time for being able to give back to the community.
Yeah, great thoughts, Kim. I think about a couple things in terms of how to try to be a good role model for younger students. Of course, I didn't think about that when I was a senior student, but I wish I had thought about it more. I think one is, be around, like just be around and accessible to some extent. I'm a little worried that our post-pandemic life is going to be a little more Zoomy and a little more work from homey than it used to be, or maybe a lot more. And I think it's really easy to miss out on all these little interactions you can have with people. So I really encourage people to try to be around and available, because, just sometimes a 2-minute conversation will change how you think about things. And it's really hard to set up a meeting for every interaction you want in your life, especially with, especially younger people asking you, like an older person, for your time. It's much harder to say, can you, hey, can you spend an hour and talk with me about something, rather than you see someone in the hallway and you chat for a little bit. So I think being around is important. I think another thing in terms of being a good role model is just being a reliable person. If you say you're going to do something, do that thing. Don't disappear. Don't not get the thing done. I think reliability is really important, and you kind of want to model, how to be. It's interesting you're talking about that balance. Education is fundamentally a selfish process, right? We don't think of it that way. We think we should get educated, so good, but it's selfish because it's about you're getting educated, right? You spend the first many years of your life being educated. And why? Well, because presumably that education is going to make you a better citizen, a better person in the world, to help the world become better. But while you're getting educated, you're not doing any of those things, really. You're kind of absorbing. And so I think you always should think, be aware of that it's a selfish process. And so some time spent helping others through that process is not so bad. You do have to be a little selfish to get, your research done. You can't completely put your research aside and help others all the time. It's true, I think. But I think it's, mostly realizing that you're spending a lot of time on yourself, even if you don't think you are. So having a little time for others is probably a good thing. And you'll find that, there's a lot of joy in just kind of working with people and working through things with them, and being around and reliable for others, I think is super valuable. So I think it's going to be hard to get that balance wrong. People will naturally kind of lean towards making sure their own lives are kind of moving forward the way they want.
And I think just to add on to that idea, you develop really useful life skills in helping other people, right? And in actively mentoring people, in teaching people, these are lifelong skills. And if I hate, this is kind of crass what I'm going to say, but there as one becomes more senior, this becomes a dimension that is used to, sort of say, is this person, a good person to promote? Is this person a good person to, sort of, to be a leader? And so by providing mentorship and help to others, you're developing those leadership skills that are going to be important to you as you move through various phases of your career. And I think that's although it seems like you're not paying attention to your own career at the time that you're doing it, you actually are in the long term paying attention to your career because you're developing these leadership skills and these mentorship skills that are going to be really important for you to have later on.
Yeah, that's a really great point. If I could just add to that 1 second, like, I often think about one other aspect of that, which is like when you're trying to explain something to someone, if that's a thing that when you do it, well, you're benefiting them, hopefully, that they're understanding something. But for me, I always think about that from the perspective, it's like I'm learning how to be a better teacher, right? Just to how to explain things to people. So I think along all those lines, leadership, mentorship, teaching, like all those things you kind of benefit by having interaction with younger folks and kind of seeing what works and what helps people kind of further themselves.
Okay, thank you both for your answers. And now I guess we're in the final minutes of this AMA, and we'll end with a last question for both of you. So if you weren't a computer science researcher, what would you be? And I have to warn you that a singing breakout room may be created after this question.
That's funny. I'll just quickly answer that. Like, I met an old friend of mine recently, and he was a very argumentative kid, and I said, Ash, his name's Ash. I said, I always knew you'd be a lawyer. And then I was expecting to say, Ramsey, I always knew you'd be a professor. And he said, Ramsey, I always knew you'd do something with computers. So apparently I was like viewed as a computer kid even when I was in 4th grade. So I have no idea, but I always did like computers. I guess I was attracted to academics, so maybe professor of something else, but who knows if I'd be good enough at that. So anyway, that's my quick answer.
I'm sure that you would be. You're very good at explaining things and guiding people through things. So I think you would find some way to mentor folks. For me, I think, yeah, so music is definitely up there. From the time that I was a really, really young kid, I wanted to be a school teacher, and like everybody in my family was a school teacher. And so, to this point about role models, you kind of see things and you think, oh, I could do that too. And so I think that if I would either be a musician someplace or I would be a teacher.
Okay, so I don't know if we can thank the speakers. Yeah, I'm the only one with my mic open, so sorry for the very small claps. I guess I'm gonna give back to Amy or Natasha and let them create a breakout room, I guess, because of this last answer.
Okay, thanks, Rita, and thanks, Ramsey and Kim. Of course, as always, it's great to see you guys interact and see what senior role models in the community look like. Thanks for also being awake at 7 a.m. Pacific time. Although I guess Ramsey's, in Central time. So no thanks to you for being up this early.
Thank you.
All right, thanks guys. So now there's no break now. We'll have a break in an hour. John Wilkes is here already and gonna run his elevator pitch competition, not competition, just like run how to do an elevator pitch, which as Natasha said earlier, you think you know how to do it, but you don't. And this is a great way to learn and great place to learn because this is basically how you're networking and meeting different people and meeting collaborators is sort of giving them a pitch on what you're working on. And that's how you start, talking with people in the community. So I think John is actually here already. So John, do you want to take over and also present slides if you have them?
Sure. I think you need to let me screen share.
Ooh.
Well, we can do it without. But
This
yes.
is testing the limits of my skill set. All right. Natasha, help. How do we make John a host?
I think I've done it.
Yep, that seems to help.
I'm so relieved to hear you say that.
Can you see my screen?
Oh, good.
That was a question. Can you see my screen?
Yes.
Excellent. Good, good. So good morning, everybody. I think it's most people's mornings, but welcome. Hi. So one of the things I notice is that lots of folk don't have a quick, snappy elevator pitch come back when somebody says to them, so what are you working on? The result is when they run into somebody they might be interested in talking to, or somebody they don't know yet, and would be interested in talking to if only they knew, they don't have a way of saying, great, here's what I do, here's why you might be interested in continuing to talking to me. They get a bit tongue-tied, and the result is sort of a missed opportunity for a conversation. So what we're going to talk about today is a really quick trick with sort of just four sentences, which would allow you to answer that question and have people go, oh, really cool, that's great, let's talk some more. Or that was really cool, thank you, not the stuff I'm interested in, but that person over there might be a really good person to talk to. We've never tried out, at least I've never tried out, an online version of this elevator pitch thing. I've always done it in person in diversity workshops and things like that. So I have no idea how this is going to go. I don't know if it's going to work, but as a result, we don't have the techniques down pat for working out how we can help people who can't make to a physical meeting like this. So what we're going to do here, we're going to try one live for the first time. We're actually trying a live thing with breakout sessions and other fun stuff. We'll see whether it works out. And if it works, we will do two things. One is we'll probably get less bad at it for the next time. Second is we'll get some feedback from you. And the third is we hopefully will be able to take this thing on the road, make it more available to other people. Landing networking in data centers after the machines show up is actually something that happens. It makes the machines late. Machines turn out to be quite expensive, roughly sort of 10 times the price of the networking you'd have to put in place to support them. So as a result, Google back in 2019 was wasting tens of millions of dollars of money a quarter by not having networking arriving before the machines it wanted to plug into. So we fix that by just saying, great, let's not pretend that networking is going to be as optimistically on time as we think it was going to be. Let's actually just plan for the fact that it's going to take twice as long as we thought it would take. And buy a little bit of extra networking, relatively cheap compared to the machines, and focus on sort of 99th percentile delivery times for the networking cycle time rather than just the optimistic average. Result, we spent a little bit more money on networking buffering, buying a bit of extra networking earlier, and the number of machines that got stranded by late networking dropped to 0. Cool. Those were just 3 examples of what I call elevator pitches, right? They lasted about somewhere less than a minute each, and they all had the same structure. This is that structure. It's the answer to 4 questions. These are not mine. I wish they were, but I found them. I'll give you a pointer later to where they came from. But as a way of structuring a response to the sort of, hey, what are you up to? I found this really helpful. I use it all over the place. I use it in sort of interactions like this. I use it in my paper abstracts. I use it in sort of getting other people to think about how to describe what it is they're trying to propose we do. It's not the only way, please don't get me wrong, right? There may be plenty of other good ways of doing elevator pitches. This is just the one that I find helpful and useful. So that's why I'm sort of sharing it here. So the structure is quite simple. First of all, a problem statement. Secondly, an explanation about why the problem is a problem. Why does it matter? More about each of these things in a minute. The next is the positive startling statement, which is really sort of, and here's what we're going to do about it, about that problem, not just things in general, but that particular problem. And then the last final one is really just sort of putting the bow on the thing, sort of, hey, look, aren't we clever? We actually managed to solve the problem we began with. And the consequences, the positive startling statement are indeed positive, and they fix the problem. So basically what we're going to do today is we're going to go practice doing each of these things. With luck, the breakout technology will help us do this. But before we go in, let's talk about that first one, because it's by far the hardest of the set of things we were to say. So a couple of ways of asking the question. What problem are you trying to solve? And the word problem and solve actually both matter. In particular, the problem part, it's really helpful to focus on things you can't do, or things that are painful, or things that are expensive, or things like that, right? So those are problem statements, right? So we can't today deliver networking on time. We can't today have practice because we haven't tried this yet. Big breakout sessions for online sessions. We can't, etc. Right? Lots of people, what I've discovered is that they want to leap to, and what I do is, right? But what I discover and I found for myself is, and I think other people may share this, is that it's really hard to be motivated by, I'm building a foobar. Why? Why would I care about the fact that you're building a foobar? And it turns out that getting people motivated about the thing you are doing, building a foobar, is often easier done by saying, and here's a thing that hurts, and building a foobar will fix it. So the problem statement is focusing on what it is that is not right, as opposed to I want to X. So if you start by saying I want to X or I am building Y, you're sort of missing the point, right? Sort of lots of people will launch into I'm building a system to do so. Yeah, so why? Why would I, as somebody who's sort of run into you in some random conversation, or anybody else who might have met, why would they care? So really, think of the problem statement as the motivation, right? So this is how you explain to people what it is you are going to solve. And then trying to solve turns out to matter as well, right? It would lovely, world hunger is actually a genuine problem. But most of us, sadly, don't have the ability to solve it. So we're probably working on some tiny portion of a thing. So another thing I see happen is that people feel that if they were to explain what they were actually solving, it would feel too small. Yes, totally sympathize with this, right? In practice, though, it turns out if you describe a problem that is too vague and too broad, often it has the opposite effect, right? Because the reader goes, you can't possibly be solving that. So they sort of tune out. You lose the credibility of saying, oh yeah, here's this small thing I'm doing. Well, there's this small concrete thing that I'm trying to get rid of, this problem. Instead, here is this sort of big grandiose thing which really is a description of the area in which I'm working rather than a particular thing. So the other kind of failing I see is what I call sort of boiling the Mediterranean, sort of describing a very big problem space because that feels like it's worthy of attention. It turns out, as I like to point out to people, it's very easy for a listener to take a very concrete thing that you describe to them and abstract that out to, oh yeah, that's an example of this kind of thing or this general space or what have you. It's almost impossible for the person to do the opposite, right? So if you give them a broad space, they have no idea which portion of it they're solving or time to tackle. So it's much better from the point of view of the conversation, because you only have a few seconds here. If we're doing elevator pitches, think about a minute, to get as quickly as you can down into the details. Now, the fun thing here is that you need to provide some context and background. And it has a sentence. This is the why, so it's a fun exercise. And this is what makes it hard, probably the hardest one of the 4 sentences to write or to think through or to say. So the fix for this is to try it. So here's what we're going to do. I'm hoping that my colleagues here are Zoom gurus, because I'm not. We use Meet at work. We're going to do a breakout session. And everybody's going to get randomly assigned to a breakout session, I hope. We are going to ask you to disappear for, what I'm going to say, let's say 4 minutes after I say go. We're going to keep a timer. We're going to be trying to keep on time here because we don't have a huge amount of time. That means by my watch, we're actually going to be back at 15 minutes past the hour by the time I finish explaining this slide. So what we want to do is, with luck, you'll end up in a session with maybe 2 people, possibly 3. What you want to do is to try out your problem statement. Try beginning with the phrase, the problem I'm trying to solve is, and actually answer that statement, right? Sort of each of you gets to try it at once. If time permits, and I hope it will, sprint, I can't spell when I'm in a hurry, 15 seconds, just give a bit of the gift of feedback for somebody. Hey, that was good, but this thing didn't come across, or you could have said this other thing. And then if time permits, just try it again. Everybody in the session should get a go. And then come back at 15 minutes past the hour. If we could do the breakout thingy right now, Amy, Natasha.
Yep, doing it. Everybody's gonna get randomly assigned now. Did it work? No.
Oh, it did.
It looks like everybody has to stop and join. So just go press the stop and join button. You'll be back. Several of you haven't pressed the stop and join. Go, go. Time is ticking. Yes, this means you. If you're hearing me, go.
Give me a sign. I think everyone is in a room with at least one other person.
Yeah, I got invited to somewhere else, so I should probably go join them.
I can also move that person to a different room if you prefer.
Why don't you move that person to a different room? That would be great.
I'm still recovering from my first elevator pitch interaction with you, John, so I feel like 50 minutes in, you know, in a closed setting with no possibility for escape is
You got off lightly.
I have this distinct memory of talking to Alan Clement and calling him and saying, like, after a talk that you came, I gave to you, came was like, they were asking me what a transaction was. I didn't get past my second slide.
So that took us about a minute to send people off to the other place. So I think we should maybe call them back at 16 minutes past, if that's okay.
Yeah.
Great.
I thought there was a way to forcibly move people into breakout rooms, but I guess not. I wish we could do that because now we have to wait for everybody to press yes.
What do you mean?
I thought once you created breakout rooms and assigned everybody, you could just boot them out and boot them into their breakout room.
Yes, but when they say not joined, they have to.
They have to press the, how do we drag them back?
No, I can close all rooms and then I can
Okay, all right.
drag. Yeah. Hopefully. We'll find out.
Do we have the option for doing a vote? Can we do a quick online vote? Is that a technique that we have available to us?
We can do it on the Slack.
Yeah.
We can direct everybody to the Slack.
We can do a poll and quiz.
Yeah, I was thinking of a poll. Was in terms of timing, was that enough or too much?
We can do a poll here.
So people are coming back already, so that's interesting.
Well, I think that those are people who, for whatever reason, weren't in the Zoom.
Ah, okay.
There's now one. Oh, let's see. Yeah.
Oh, thanks, Amy. Great.
Well, yeah, I hope people in the in the breakout rooms got that.
So if you, Natasha, if you'd be able to do a poll, was
Yes.
that too much or too little? Or about right? That would be awesome.
Oh, it's taking me to the different.
If not, don't worry too much. We'll just wing it.
All right, time to drag them back.
Yes.
Doing it. Oh no, they'll all close in 60 seconds. How do I?
That's fine. Don't worry. It'll be okay. We're learning. All good.
Did anyone see a poll arrive?
Oh yes, it's in the bottom, but I don't know if other people can see it. It's like right next to share screen.
You could have it. Yeah. For next time, we should ask about right. So that's.
Oh yeah, sorry.
No worries.
It was definitely not exactly right.
Yeah.
All wrong.
We should assume we didn't get it right, but.
Right.
I was a little pessimistic in the outcome of the poll. So just assume the next time there's also an option to say just right.
Great, yes. Looks like a fair number of people have come back. Awesome. Yeah. Cool, so those of you who've probably seen this, let's try that again. With luck, you should see at the bottom of your screen a poll that can say, was that too much, too little? We forgot to put on the option of just right, but if you could just vote quickly, just take 3 seconds and vote and press submit, that would be great, because we'll use that for our next breakout session. Cool. So like I said, that was probably, yeah, the first time I could do this, right? I know how to do this. And actually it turns out to be hard. It's you have to think about it. I mean, I actually ended up writing notes to myself when I was practicing for this thing to sort of force myself to sort of, what do I actually want to say for each of these things? That's okay. We'll get more chance to practice more of that, because what we're going to do now is we're going to take the same idea and add the next sentence to it, right? Which is really the why is the problem a problem? So the motivation is really 2 parts, right? It's the problem statement. And it turns out most people are smart enough to go, oh yeah, I can see why that'd be a problem. But you can also help them by saying, and let me explain it to you just a little bit. The goal here is to really translate the problem into the consequences of the problem, right? And usually that consequence is money. Something costs too much, or it's too painful, or we have to spend too much things, or things are inefficient, which means we have to buy more stuff to compensate for the inefficiency. Or very occasionally, if you're working one of those places like sort of healthcare or nuclear reactors, somebody could get hurt if the problem goes bad, goes south. So hopefully most of us are not doing that, but so that's relatively rare in our field. There may be folk in hard real-time stuff for whom that's an issue, but for most of us, sort of we're typically engaged in sort of capability or money, sort of costs or profits or scale or efficiency or go faster, which often translates into if you can't go faster, then you have to compensate for it somehow. So the target here is to explain to a person who may not know your space, right? So think about the audience, right? They may be very, very smart people, but know nothing about your particular problem domain. So you need to help them sort of map from the thing you know, because you're deep inside the guts of this thing, into something that they care about. I was once in I think it was an ARPA PI meeting. All of the very, very smart people were talking about here's why the stuff they were doing was so important and impressive and desperately needed funding, and they should be given boatloads of money, large quantities. And there was a staffer from one of the Washington came down. I still remember this all swept in with a greatcoat and sort of made a wonderful impression. But the question they asked was amazing. Why would the people who vote for my congressman care? Why would they want to fund this? Which is a great question. And this really is the nub of the sentence we're trying to get an answer to here. Why would they take the problem statement that you had and turn it into something they care about? I always joke about my mum, right? She's a super smart woman, knows nothing about computer science. But if I can explain to her that this thing might matter to her, cool, great. That's sort of a level of stuff that would be really cool. So we're going to do the same trick as before. Do we have any data from the poll about the length?
It was either most people focused on too little, so no one said too much.
No one said too much. Excellent. All right. Well, this time we're going to give you 5 minutes. We'll do the same trick as before. Now we know sort of a little bit how it works. So same deal. What we want to do this time is you want to practice the first sentence and the second one. And I'm assuming that the random thing will end up with pairing you with potentially different people. So you're going to have to do both things. So this gets you a chance to re-practice what is the problem statement that I'm trying to solve. Remember. And same thing. Let's come back this time at 26 minutes past the hour. So that should give you about 5.5 minutes. Please go join.
Natasha, you fired up the breakouts, right?
Yeah.
Okay.
I also created a poll with 3 options this time.
Why have I lost my chat option? So when you're presenting, where do all of the controls go?
There should be a Zoom bar.
Oh, I see, right. It floated to the top, yes. Great. Somebody said just right. That's nice. So I'm going to let you talk about the pricey thing. I've got one slide with the mechanics and a link. I created a tiny URL, but I'll let you talk about motivation. Is that okay?
Can I request a different room?
Sure.
Yeah. Oh, was there nobody in your room? Sorry about that. Who
No,
said
there were
that?
people, they just weren't talking.
Oh, I see. So this is Elizabeth, right? I'm gonna move
Yeah.
you to a room.
Thank you.
Seeing a young new PhD student, Jeff Mogul, in one of the rooms.
Sorry, I didn't hear that. Say that again.
I said I'm seeing a young new PhD student, Jeff Mogul, in one of the rooms.
Ah,
But is,
good for them. Yes.
I hope his elevator pitch is on point.
I was going to hope you'd learn something.
I definitely failed to give one to one of my students like a week ago when I was trying to illustrate how hard it was and like completely stumbled on a new project.
It's quite easy to demonstrate how hard it is. Yes.
Yeah.
Thanks, Amy.
Tasha, is there a way to delete your previous poll? Because now there are 2 polls active and there's like a drop down where you have to create select. Do you see this?
Yeah, let me try.
There are 2 untitled polls.
Somehow I can't do.
Or if you could rename one of them to
Yeah.
new poll, use me.
Well,
You should see Bissing poll.
Yeah. Poll 2. Okay.
Yeah, somehow because the poll is finished, I can't. The
interesting.
first poll is finished, I can't rename it or edit it.
That's
Oh, well,
fine.
never mind. That's okay. Hey, we're learning. Let's bring people back, I guess. Yeah.
Okay, yay. Breakout rooms are closed. John? You wanna?
Okay, people back. All right, great.
Yep.
So again, there's another poll if you wouldn't mind answering that. That would be really cool. So thanks everybody for sticking with this. Interesting sort of, normally when we do this live, this, when everybody's doing their conversation is when the room is filled with a buzz of energy. And here we are sort of watching this thing in silence. So we have no idea. We're hoping it's going well. Do please use the chat. If you end up finding yourself in a room where, the only person or the other person is not responsive, they've gone off to get tea or something, just ping us or come back and we'll happily reassign you. We'll try and make sure you get a chance to try this out a couple of times. All right, so we're making progress. So that was sentence number 2. The next one is, in some sense, the easiest of, well, almost the easiest. This is where you get to say what it is you're doing. Here's your clever idea. Here's the smart trick you have for solving a problem. So for us, not knowing how to run one of these things, our smart trick is, let's try it, see what happens. So really, this is where you want to say, this is the clever idea, right? So you want to land the motivation, which is the problem statement, followed by, and I think I have an answer. And ideally, this is sort of what people remember. Oh yeah, they were solving an interesting problem and they had a clever idea, which will go away. And either what a couple of things can happen. Either they will go away going, oh yeah, interesting person, would like to talk to them again, or they say, great, that was 30 seconds, here's another 5 minutes. So they actually think of it as buying time, right? Sort of by being an interesting conversationalist, you get a chance to keep talking, and you get a chance to ask questions and sort of slowly build up an interaction with somebody. So a couple of tips. This is really where the audience can generalize, but they can't make up concrete details for you. If in doubt, provide more details than you think is necessary. A lot more details. The other thing I've watched happen is people try to explain stuff to other folk. Right? If you've ever been on the receiving end of mansplaining, you'll know how frustrating this can be. Don't assume your audience is actually incredibly smart, because most of them are. Most of you are incredibly smart. That's why you're here, right? You have the skills. Just dive straight in. If they don't follow you, they can say, oh, could you explain something to me? But there's no polite way of saying, could you speed up? You just have to sit and wait. So my usual advice for this is to be very concrete, very quickly, and go straight to the details of the interesting thing that you're talking about. Don't abstract it, be concrete. Let other people do the abstraction, because we have years of practice, most of us, you too, right, of looking at things and sort of go, oh yeah, this is one of those things, and you're matching it with that. Cool, people can do that on the fly, but they can't do that if you don't give them the detailed information. Yeah, so don't summarize, don't simplify, be as concrete as possible. Maybe that's the best single word to remember for this thing: concreteness, concretization. Okay, well, enough already. You know the drill. We're going to send you off. Actually, how's the poll? What's the poll telling us now, Natasha? You're on mute.
Attempt 2, vast majority of just right.
Excellent, good. Well, we'll do the same thing. Come back at 36 minutes past the hour. Actually, make it 35, because what you're going to do is now 3 sentences, right? What is the problem? Why is the problem a problem? And then the positive startling statement. So that's 36 minutes past the hour. We'll see you again soon.
I think everyone has at least 2 green dots in the room.
Nice. Cool. So I don't see why you should lose out. Amy.
Oh gosh, this is bad. Okay.
You should always be ready.
I know. What's the problem? The problem is in distributed control planes. Distributed control planes have to compute on a lot of state. And this state is like state of the data plane that they have to use to make decisions on. And so this state is a bottleneck for how fast control planes can run. That's the problem. Oh no, is that a good enough problem? Is it a precise enough problem?
Try it. Keep going.
All right. So what are we gonna do? Right.
No,
so
no, hold
what
on. Why is that a problem?
Oh yeah, that's a problem because now control planes are basically bottlenecked by how large of systems they are able to efficiently control because they're bottlenecked by how much data they can like store and compute on.
Good.
So you can only limit, the system or the data plane to, a couple hundred nodes, say.
See, concrete. Good.
Yeah. Positive statement.
Yeah.
So what we do is we observe that control planes only need to compute on the changes or the deltas in the state of the underlying data plane. And so we observe that now control planes only need to compute on data that is linear in the size of changes in the underlying system rather than linear in the size of the state of the entire system at any one point in time. And this is how we greatly bring down how much data the control plane has to pull in to make a decision and how quickly it can make that decision.
Nice. And then you could do the last sentence too. You know what's coming.
What is it like? How? What is?
So what's the consequence of the?
Oh,
what's
the
the
consequence? The consequence is now control planes can easily manage much larger systems, and they can scale up to control much larger systems. Yeah.
Cool.
Cool.
Yeah. So the only suggestion I would have is provide a little bit more context about what kind of control plane you're describing. But yeah, that's great. See how easy it is to go concrete. Sort of 200 is so much more anchoring than some.
Right. Yeah. All right. When are we dragging people back?
We should
give
probably
a warning?
a minute and a half. So give them a warning. Yeah. And yeah, these are things that that you have to think about, right? It's hard to dredge them up on the spur of the moment. Yeah, but and practicing is helpful.
Yeah, you need a forcing function, because if you, for example, aren't going to any conferences, all this virtual stuff, like I haven't had to describe my project in a long time, or I'm just talking to my coworkers who I work with.
You sort of know it. Yeah. So I've started asking this kind of question for, people come up with proposals of, stuff to do. And I go, great, good. What is the problem? And, some of them get it, others need help. But it turns out and then for us, it turns out, we the way we answer the second question is sort of basically business benefit. So now we've got a stack rank of things we could do sorted by the business implication, the second, why is the problem a problem? And cool, right? We've sort of mostly done it's not mostly done, we've half done the prioritization exercise already across all of these different things that could be done.
Yes.
Yeah. But two of us ended up writing a 2-page document about how to write problem statements because it turns out people don't have a good grasp of what a problem is. They tend to write all sorts of everything that they can think of in the kitchen sink about why we should do this. And no. The question is, what problem are you trying to solve? The later you get to tell us all the things we should do, but they want to leap ahead, go straight to the all of the stuff I want to say. No, slow down. Trust me, it'll be quicker if we do it one thing at a time.
Yeah, no, it's good to know that even people, engineers at Google need.
Oh yeah,
right?
This is people, right? They want to tell their story.
Yeah.
Great. Welcome back, everybody. Hope that was fun. Should probably do it. Was this fun? No, later. Okay, great. So good. 3 out of 4. We're almost there. The last one is actually, in some ways, the easiest. It's just, I solved the problem. I mean, that's really the way you have to say it, but you have to disguise it in some way. Sort of, say, no. Actually, as Amy's example was, we have a control plane that can only cope with 200 things, and now it's 1,000 things. Oh, cool, great. This really is just sort of tying back to the reminder that problem I told you about, but we've fixed it. We've actually fixed it. One of the reasons this is, it sounds sort of trite to have it in here, but it's actually really helpful when you're writing the paper abstract. This is where all the numbers go. This is and we scored 2x the scale or 4x latency reduction or etc. Right. So this is where you drop in all the bragging rights about the positive data you get from your measurements and experiments. And the important thing is to sort of really you want to tie it back to that original problem statement, because you actually want to solve the problem, all of it. And if it turns out your conclusion is, well, I've solved a little bit of it, then you want to go back and rewrite the problem statement, because it's probably too broad or too vague, and therefore not actually the problem you're solving. It's a problem, but maybe not the one you're solving. So this finally sort of put the bow on the thing. So now you have all the tricks you need in order to be able to do the whole thing, beginning to end. So let's try it again.
You're muted, John.
We pushed them out a little too soon. I was going to tell them a timer to come back.
Oh, we can tell
Yeah.
them.
No, it's fine. We can tell them. Yeah. So
yeah,
let's say 42. Yeah. Actually, 43. If it's not too late.
It's okay. We'll just
Yeah, we can.
42 will stay in there.
42 will stay. Great. Yes.
Yeah.
So I've got two more, which basically is a summary and then the prize. So here's what I was going to suggest. Float for the prize. Then I could basically hand it over to you to say, and what the prize is and things like that.
What's the prize, Natasha?
Yes. I don't think let's go to chat.
Yeah.
Yes, yes.
Somehow I ended up in an empty room, or actually a joining loop where it never joined me to a room. So I give up.
Okay.
I actually had, I'm doing this on my iPad. I actually had to just quit the app. There was no.
Oh, right. I got a leave room option.
Not sure what happened, but I think he's in a room now.
Yeah, but I think he just added himself to room. I don't know. Oh well, he's there.
Yeah, whatever. One minute warning, maybe.
Yeah.
Do you have the option to unmute everybody who wants to be unmuted?
No, I think everybody just has to unmute. And
Okay,
they can if they
but
want.
if they can do it themselves, you can give them control. Yeah, I was going to sort of do a Q&A thing at the end.
Ah, okay. Yeah, we can do that. I think we can just have people unmute. It's
Okay,
yeah.
great. And you want to finish at about 10 to, yes?
Yes. Oh, actually, we have a break afterwards, so you can go to the hour if you want.
That's fine. We're going to be finishing before then, I think.
Yeah, we have you scheduled for the hour, so feel free to.
Oh, okay. All right.
No pressure to finish 10 minutes later than you thought, but there's some
I mean, I need to speak more slowly. Pat it out.
I think there's an option on Zoom to do that, right? You can like do 2x faster. We can do.
Yes. It's annoying. It doesn't work on live. It's really frustrating. Guess we can start pulling people back.
Yeah, I did already. John, are you on Slack? I had a question for you. Or should I just Zoom chat
No,
you?
unfortunately, I'm not.
Okay, I'll Zoom chat you.
Yeah, thanks. I was going to get set that up later in the day, and I didn't manage to get up early enough to do it. So. Oh yeah, please, sure.
Yeah. Okay, I'm gonna go do it.
All right, welcome back, everybody. Thank you. Hopefully this gets a little easier with practice. That's what I usually find. It's the first time it's yeah, and then but by the third time you say you're sort of nailing it, and then you're like, oh good grief, no, actually I could do that. I could still do better, right? Sort of like the conversation that we were having earlier, right? So you want to get to the point where you're comfortable with it. The nice thing is this is something you can practice, and it turns out practice does help. You can do it with your friends. You can do it the next few days. I mean, there's one of the reasons for doing this in this session is to give you a chance to sort of get comfortable having this conversation with people that you run into in sort of Slack sessions and things like that at SOSP. So would strongly encourage you to take advantage of this, right? Some wonderful people out there. Go say hello. They're humans too. They would love to be very flattered to be asked for a quick conversation, I'm sure. Do take advantage of this. And now you have a sort of little story you can tell. So I always encourage people to, hey, I'm John, and the problem I'm trying to solve is actually a great way to do an intro to somebody. And the good news is if they've seen, and many of them have, this kind of sort of session, they will know that awesome, right? It can't last more than about a minute, even if it's terrible. It won't be terrible because you've done the practice, but this is a nice way to sort of to break the ice and get a chance to have an intro. And then, you can take it from there, right? So the rest is up to you. So here we are, the 4 sentences together. Like I said, just repeat, this is not the only way to do this. It's the way I found helpful because it forces you to think really hard about question number 1. What is the problem you are trying to solve? Why does it matter to other people? And it really is sort of mapping it down to what's the consequence of this? Positive starting statement, that's where you get, and here's clever, that's a really cool idea. I'm doing something novel here. I'm doing something really interesting. I'm pulling things together from 2 separate fields, each of which is well known, but the combination hasn't been done before. And then the consequences was, and by the way, the numbers look really good, and the problem is mostly solved, and etc. Right? Please hire me, or whatever it is that you want to try to land as the thing to remember. I largely lifted a lot of this material from this panel session where Kent Beck talks about the 4-sentence abstract back in 1993. You can find that at this place. You can just search for it as well. And he sort of provided a bunch of wisdom there, some of which I've distilled and tried to simplify for the conversation here, but it's basically the same message. And then I've also written something for those of you who do posters. One day we'll get back to doing physical posters, which would be awesome. You can tell a story the same way, right? So the question, I'm standing in front of the poster when I'm talking to somebody and the first question going through my mind is, what problem are you trying to solve? So it's really cool if that's the thing on the top left-hand corner of the poster. And then you can actually structure much the rest of the poster along this way, right? Sort of, why does it matter? Positive starting statement is basically, and here's the clever idea I have. That's a middle section, and then there's some results, which is the consequences, and then you tie back to say, look, see, problem solved, right? Sort of there you go. There's the flow of your poster. If you haven't got those things, it's really hard to understand what it's about. Remember, the posters have to be read when you're not around or you're busy talking to somebody else. They have to have a smallish number of words. It's very easy to put essays on. Don't do that. Anyway, great. So that's basically it. Thank you for playing the game. I hope it was at least slightly useful or interesting. And maybe, like I said, practice makes perfect. Do take the chance to practice, because these things do get better with time. And then just for one way to help you practice, we're going to offer a challenge, right? So this idea, I want to credit Natasha and Amy for coming up with this. How about you send us a recorded elevator pitch, audio, video, we don't care. We're really not interested in high production values. We're interested in the content. There's a form here you can go to, tiny URL, UBW64993. It'll take you to a Google form. It's going to look something like this. It's got a bunch of stuff.
Oh, wait, you're not sharing your screen anymore, John. So like, we're supposed to see stuff.
Thank you.
Yeah.
Sorry about that. So here, in that case, you probably missed all of this stuff too. So here is the fourth instance abstract by Kent Beck, and creating an effective poster. That one's easier to remember. The first one you can find just by your favorite web search. And the second one you can also probably find with your favorite web search. Strongly recommended. So here's the challenge, right? Send us a pitch. Send us an elevator pitch. Natasha, Amy, and I will take a listen. Or a look. You have 24 hours to get it in, so feel free to record it in whatever technology works for you. Upload it. There's a form. The form will look like this, a bunch of stuff, and there's a place to upload a file. Keep it short, sort of a minute would be ideal, and sort of get it into us about by this time tomorrow. And you have an option to allow us, if that's okay, to post the result on the workshop website, just sort of so we can show off good examples of this. And we'll do some arbitrary decision-making, selection criteria, choice-making thing, and then Natasha and Amy will talk about the consequences of once we've made out this arbitrary decision-making consequencey thing. Amy.
Yes. Okay. So we have yet to decide what the prizes will be, but Google has very generously agreed to sponsor them. So I think we will just, if everybody puts their email address on this form, we'll contact everybody after the submission deadline to give you guys updates. Yes.
But it's mostly the fame and the fortune. I mean, think of it that way, right?
Yes.
and a fun way of just something fun to do to try it out. So get one more chance to practice.
Yeah. So yeah, I think that's really it, is one more chance to practice, and then hopefully the three of us will also try to give some useful feedback. But I think, yeah, regardless of whether or not you win a prize, I think doing it for the feedback and the practice will be really nice.
John, I think there's some technical difficulties with the tiny URL you posted.
Oh. Okay. Interesting.
So I think several people are getting unable to find URL, including me.
Oh, I typed it in incorrectly. That's on me.
It's an HTTPS, if that makes a difference. But...
No, I think I reproduced it incorrectly. Yeah, yeah,
you chatted it. Okay, fine. Yes, yes.
Yeah.
Got it. Thank you.
Okay, John, did you want to open it up for questions? So
yeah, please. Right.
Yeah.
So that's basically it. You've graduated. Well done. Congratulations. Happy to. I'll be sticking around for the next sort of 10 minutes or so. Happy to answer questions. Feel free to drop out now. Go stretch or something before the next thing. It's really good to move around if you can. But yeah, happy to answer questions either in chat or live, whichever you prefer. Feel free to unmute yourselves.
And if you are heading off for a stretch, we'll be meeting back at 9:15 for the topic focused breakout rooms. So if you can, try and make it back at 9:15 for this. Thanks.
John, can you share the slides? Is that possible? Some people are asking.
Yeah, sure. How long must the video be for the pitch? Try to keep it about a minute, right? It's meant to be an elevator pitch. So the goal is to keep it short. Oh, for those of you who are still on.
I love this advice.
Oh, many of you, many of my colleagues do, end their slide deck with a thank you slide. Don't do that. Don't do that. No. Go back to the thing you want people to remember. this one, or in this case, this, right? Sort of. So that's leave it up while you're doing Q&A in a talk or something like that, because then the key ideas will be soaking into people's brain. There are a few more frustrating things if you're taking notes about some session. People typically are running late and they're rushing through their last slide and they move on to a thank you slide, which has no content in it at all. Leave up your conclusions instead, so people who are can make notes about them. I will, yeah, the slide stuff, let me stop sharing.
If it's like Google Slides, you can just share a link to it, right? You don't have to like.
Yeah, it turns out this is owned by my work address, and Google doesn't allow arbitrary internet sharing for work addresses for reasons.
There's a question for you, John.
Yes. How do you know the right
Okay.
level of abstraction for your solution explanation? How smart should you assume your audience to be? Assume infinitely smart, and probably don't do too much abstraction, right? That if you can put concrete examples in your explanation, it'll be much easier for everybody. Like I said, there's no polite way for somebody to say, could you give me a concrete example? Because that's too vague. Whereas if you give a concrete example, most people will be able to sort of do the back matching to the abstraction. So if you're not sure, start with a concrete one and then work your way out. But I would strongly encourage you to go in depth as quickly as you can. If you could drop numbers in, that's even better. Examples of, do you remember the time when? Concrete thing would be super helpful. Or we've actually done it for these two examples. So again, be more concrete than abstract. So if in doubt, err on the side of concreteness and go more detailed than you expect. So if you're unsure, provide more detail. Elizabeth, yeah, good. Yeah, sure. And if you want to unmute and give us a try, we're happy to chat with you.
No,
about
I don't even know what to say for 3 and 4. That's the problem. It's like, okay, so the exploit I'm currently working on is using user level code to pseudo make kernel level functions. Obviously, that's a really bad problem because kernel level code is supposed to be protected and not available to the user space. And then 3 and 4, I'm like, what am I supposed to do here?
Hold on, sorry, what was the problem again?
What am I supposed to say for 3 and 4?
No, I understand, but what was the problem again?
Oh, I'm basically finding an exploit where we're using user level code to force kernel level functions.
Sorry, your goal is you can't find such examples, or you
to force them
fast enough, or you're sorry, try that again. What is the problem?
We're using user level code to
no,
force...
we're using is not a problem statement.
Oh, the current exploit that I'm working on.
Okay,
is,
so there is an exploit which is using user level code to do something bad. Yes.
Yes.
Cool, great. So that's clearly a problem because invasion. What are you doing about it? What are you trying to fix? How are you trying to fix it?
Oh, we're still in the middle of actually like finding all of these exploits, and then I guess testing the limits of what's possible and what's not possible.
Okay, great. So you're phase 1, you're still learning. The second is sort of when you're trying what's possible and what's possible. What have you tried?
We're in the middle of single stepping through a function. So basically, we're forking a bunch of processes, basically forcing the scheduler to turn into a round robin kind of deal, where the victim code will only run one instruction per cycle or per switch, context switch.
Okay, great. There you go. See, that's your number 3.
And then number 4 is like, well, yeah.
And does it? Number 4 is, does it work or not? Okay.
That's true. That's true.
And because you're still exploring, the answer might be we don't know yet, right? Or it only slows it down by a factor of 10. That's not enough, or something like that.
I mean, the thing is that this has been theoretically possible. It's been done before on older systems. We need to figure out first if it works on newer systems, and then second, if it works for single stepping, can it work for 0 stepping? Can we also co-locate pages? All of these other little bits.
So your problem is actually different than the one you described. right? So this is a wonderful example of sort of the too broad a problem statement. The problem is
Yeah.
you don't know whether the techniques that we used to use for fixing these things on older systems work on modern ones. That's the problem.
Okay.
Yeah, see how it's sort of a little narrower.
Yes.
Now you can
Yes.
talk about what you're doing to try and find out, and then your conclusion is yes, it does, they do work, or no, it doesn't. Does that help?
Yes. That means that I just have to rewrite my entire pitch again. Okay.
Sorry. By the way, I mean, that's great, good. I mean, this is exactly the kind of thing that happens over and over again. Sort of people think about that. Here's the area I'm working in. And what I really want to sort of encourage people to do is that yes, and what is the actual problem you are solving? The very precise problem. And people can say, oh yeah, I can see how that could be helpful in coping with this kind of problem. Well, sort of the broader area. But if you have a broad problem statement, you also need a broad solution. And that's often quite hard to do because, you know, these things are hard. Yeah. A couple more things. Oh, Hamadri, can you give some other examples, except meeting people at conferences or interactions where you can use such an elevator pitch? Great one. Paper abstracts. I actually literally write my paper abstracts this way. I mean, I will write those 4 sentences and then, you know, tweak them for ease of comprehension, but they're basically a great way of, and now you've written essentially the conclusions of the paper. You need to say, great, well, if that's what I want to say is my abstract, how do I prove it? And then basically, you know, the rest of the paper comes along. We use it internally for sort of justifying projects. We get people to essentially answer the 4 questions to say, hey, I want to go invest in something or other to solve a problem. And the first question is, good, what is the problem? The second question is, how much does it matter? Dollars, please. Millions of dollars, ideally. So we can go fix it and justify fixing it. The other is just explaining to people, you know, what do you do? You know, many of us talk to folk outside the narrow space of computer science. So having an answer to that second question, sort of why does it matter, is actually kind of fun for being able to talk to people in a bar, at a restaurant, or, you know, wherever, sort of just being able to talk. So just giving people a feel for why what we do matters to, you know, the world as a whole, rather than just, you know, graduating and stuff like that. So basically any chance you get, or when you're looking for a job, right? Sort of somebody, you can introduce yourself. Hey, I'm, you know, so-and-so, and the problem I have solved in the past is this, right? So it's a great way of just teeing off conversations. Kevin's question: what if our audience need many details to understand our work? Sometimes that's true. Sometimes, so you have to think a little bit about who your audience is, right? So if they're somebody in your area, you can certainly sort of sidestep a bunch of the explanations. But I think most people hold back and assume that the person won't understand. And in many ways, that's actually doing both them and their audience a disservice. It's much easier to start providing the details you need to provide and let people interrupt you and say, hold on, I don't recognize the acronym. And if they have to present many things, you're probably not actually solving that problem. You need to think about what is the narrow scope of the problem that you are solving. Not, here is an education about the general area in which I'm working, which is very often a conversation I find myself in. You're trying to educate me about everything there is to do with security. Well, please don't, because that won't end nicely. Tell me instead, I mean, like Elizabeth's example, right? So we don't know something about what we used to be able to do, whether it currently applies. And then, you know, if we'd had a little bit more time, I could have dug in. But the gist of the idea got across very quickly. So again, Kevin, sort of focus on the thing that you're actually solving, not education about the space. Assume people will either know it, or if they don't know it, they will probably know which bits of it they don't know, and they can ask about that if they have to. But if you assume that they are incredibly smart people who will follow you down the rabbit hole very fast, I think you'll find that 90% of them will actually be able to do that. Because the people we interact with in these kind of environments are actually amazingly smart people. You're all amazingly smart people, right? You've got to this point. So give them the benefit of the doubt and just try going deep on the details of your particular thing. And if they want more information, they can always ask for it. Cool, it's at time, so I'm going to call this. Thank you, everybody, for doing this. Let us know how it worked out for you, because this was an experiment for the first time. We haven't ever done it before. Hopefully it was useful, and with luck we will see each other in person one day at some of these things. And I actually look forward to seeing many of you in the conversations at SOSP the next few days. Do reach out to people and sort of, hey, would you be willing to talk to me about my problem? Yeah, it's a great way of getting introduced and sort of starting a conversation. Enjoy, have fun, enjoy the rest of the conference, enjoy the rest of today too. Do come back at 9:15.